Hello everybody and welcome to the next in our series on beginning Java programming. Today's going to be a relatively short video and the topic is going to be ASCII, character representation, getting a little bit more information about understanding how Java represents characters and how you can manipulate them. Now those of you following along in my course, we've already talked about the idea of ASCII. So somehow computers must represent the characters that we see in the real world in the computer. And it turns out that there's a number of ways that they do that, but one of the most commonly accepted ways is called ASCII. And under ASCII, every single letter gets translated into a number. It actually is used representing 7 bits, in practice 8 bits. But it comes down to a single decimal number, or binary, if you want to think like a computer. These are the most common ones that we as humans have to deal with, lowercase letters, uppercase letters, and numbers. And one of the things that you'll notice is that they don't start off at 1. There are other characters that ASCII deals with. 0, for example, is 48, which isn't the most intuitive. However, what does help is that as we go up in numbers or as we go up in letters, the ASCII representation goes up by 1 as well. So, B is 1 greater than A, C is 1 greater than B, and so on and so forth. And that makes things really useful to us as programmers. So at this point in our course, you've learned about decisions, and you've learned about Boolean and the idea of true and false and how we use those in if statements. Well, once you understand that characters are just represented as by numbers, and once you realize that those numbers are sequential within the range of uppercase and sequential within the range of lowercase, then this opens up a whole range of possibilities for us in terms of coding. So you know that we can represent in the computer a character doing something like this. What you now know is that when I do this, it's not actually representing the letter A. What it is in fact storing is the ASCII number 97. You also have learned that you can grab individual characters from strings. So if I have a string, let's just shrink this down a little bit. Actually, let's just expand it. So if I have a string like this, you know that I can grab an individual character from that by doing x.character at, and I can put in a particular number in there like that. So what this is going to be doing is it's again going to be grabbing that A, which is going to be represented in the computer as 97. So this you've learned already in a previous video. Now what we want to do is we want to get into a little bit more nuanced character manipulation now that we understand the underpinnings, the ASCII under the hood of characters. So I quickly modified our example. Here we are reading in a string from a console or a scanner, however you're doing that, and then now we're grabbing the very first character of whatever that string is that has been read in. So what might I want to do with this? Well, what if I wanted to sort, or I wanted to make some sort of a decision based on the first character of something that was typed in? So there's a number of ways now to do that. We know decisions, but because these letters are just being represented as numbers, we can also logic and math this a little bit. In other words, I can say things that might not intuitively make sense. I could say something like, if A is greater than or equal to. So what this is saying is that if this variable is greater than or equal to A, in other words, it's going to be 97 or more, then maybe I'm going to do something. I can combine that with something like and the character A is less than or equal to M. And so now what I've got is a range where I'm looking at everything between A and M inclusively. And in the computer, this will compare these as if they were numbers. In fact, I could replace this character with the ASCII number if I wanted to, and it would still work, because really A is represented in the computer as 97. And I could take this, and if I wanted to, I could replace it with what M was. I'm not that good at math. So this is a way to be able to use logic and characters together. You don't necessarily want to put these numbers in there. You're probably better off using the characters, because Java will make that conversion for you automatically. And it's a little more intuitive when you're looking at it to understand what's going on. So that's one possible thing that you can do, is you can use this to make decisions. That's fantastic. You can also, if you want, because a character is just represented by a number, if you want, you could actually add and subtract to that if you needed to. So let's say I had some sort of a new character, and I want this new character to be equal to A plus 2. So think of what I'm doing here. I'm taking that first character that's in here, and to simplify it, let's just call this one of my wife's favorite bands, ABBA. So it's going to take the first character A, it's going to add 2 to that A, which is going to be BC. It's going to be a value of 99, which is the equivalent of C. There's a catch to it, though. If you were to type this code into Java right now, you would be very cross with me, because it wouldn't work. And to understand why, you have to remember back to the lesson where we talked about data types and how data types have different sizes, right? Character is a very small data type, so 1 byte. Sometimes a little bit longer depending on representation. An integer is much bigger, it's 4 bytes long. So if I'm going to take a character and I'm going to add a number to it, this entire thing is going to be represented by an integer. And you know that Java doesn't like to take something that's bigger and squeeze it back down into something that's smaller. And so we learned about typecasting, and typecasting is something that you're going to have to do here as well, which is to say, take my integer number, trust me, it's within the range of a character, and turn it into a character. And then Java will go ahead and take that number and put it back into a character, and this will now be C. It will be represented by C. You're going to take the A, you're going to add 2 to it, becomes an integer 99, and then you're going to take that 99, convert it back into a character, and leave it in the variable. So that's also really neat. One of the tasks I often give my grade 12s at the beginning of the year as a refresher is something called a Caesar cipher task. And in that, what they need to do is shift all the characters in a message over one, and then to decrypt it, you shift it back. It's a little cipher. It's a bit of way to encrypt things to keep it secret. So you have to remember that in order to do something like this, you have to remember that you need to do some typecasting. You need to then take this integer, because it's been made bigger, and turn it back into a character. So what have we learned so far? We've learned that characters are represented as numbers in the computer, ASCII most commonly, Unicode in practice. And we've learned that we've reviewed kind of how to get characters and how to represent them. We've looked at how they could be made useful in decisions. We've also talked about how you can add and manipulate them, add or subtract them. The last thing that I want to talk about is just the same idea but a little different, which is how you could generate a random character. So if I asked you to generate a random character between A and Z, let's say uppercase, just to be different. Now we're tying together the last lesson on random and this lesson on characters. And one of the things that I told you in the last lesson is that when you want to generate a random number, the first thing that you think about is how many different possibilities are there. In this case with an alphabet, don't even think about ASCII, there are 26 different possibilities. So let's assume I already have a random variable and it's called RNDM. That kind of works. Or let's just make it even shorter for you, RDM. So you remember that the way that we generate a number is we call next int. And we said that there were 26 possible letters of uppercase letters, so I put 26 inside there. This is going to generate a random number between 0 and 25, right? 26 different possibilities. This is awesome, but it doesn't immediately give me the ASCII, because ASCII isn't from 0 to 25, ASCII is from 65 to 90. And part of the manipulations we talked about in the random video is how to start shifting and moving around a random number that's generated. In this case, if we get a 0, we want it to be represented by A, which is 65. So there's a shift going on here. If it's 0, it becomes 65. If it's 1, it becomes 66. If it's 26, it becomes... So it can't be 26. If it's 25, it becomes 90. And now you've got that full range from uppercase A all the way to uppercase Z. Now, if you wanted to store this somewhere, of course, you'd have to have some sort of a character. There we go. And also remember, those of you who are very astute are realizing that this is an integer and this is a character, which means we're going to have to go back to our friend typecasting, and we are going to have to turn that into a character. And so this will allow you to generate characters in a range using random numbers. What if it's not in a full range like this? What if it, instead of from 65 to 90, you want to generate random numbers that are in distinct categories? Like I want to represent a random character, a random number, or a random uppercase, or a random lowercase, right? Different categories. Or you have apples, oranges, pears, and plums, and you want to randomly pick from those categories. When you do something like that, it gets a little bit tricky, but what you need to do is think of the different categories as distinct buckets. So if I look at this over here, if I want to generate either a random number or a random uppercase or a random lowercase, I'm going to see that the first thing I need to do is decide which of these three buckets I want to work in. Well, how do you randomly choose between three different possibilities? You use a random number. So rather than trying to combine this into one big decision, you could use random to sort of choose a category first. And then once you've chosen a category, you can use random again to generate a random uppercase or a random lowercase or a random number based on what you're doing. So random and characters can kind of work together really, really nicely in that way. So that was a very short, 12 minutes, 13 minutes, that's short by our standards, tutorial on ASCII. And it combined a little bit of random, a little bit of strings together to hopefully give you a good view for some of the powerful things you can do with characters in the computer. Till next time, keep coding.